All right, question number 3. We have a toy car. It starts from rest and accelerates at a uniform rate. It then maintains a uniform speed for 12 seconds, takes 6 seconds to decelerate, total distance traveled, and the average speed of the trip. So what we're going to do here is we're going to actually split this problem into 3 parts. Before I do anything else still, let me just copy the relevant equations from the data booklet. So here we go. All right. And now what I'm going to do is I'm going to approach this problem in 3 parts. So we have a region where, or we have a part where essentially the car is speeding up. And we'll call that part 1. And what we're going to do is solve this one little part at a time. So first we're speeding up. So we're going to accelerate from rest at a uniform rate, 4 meters per second squared, and for 3 seconds. And I'm going to spend a little less time writing my unknowns here and my knowns and simply use appropriate formulas. So let's get the total distance traveled here for the speeding up part. So that's going to be S is 1/2 AT squared plus U times T. And that's going to be 1/2 times 4 meters per second squared times 3 squared. So that's going to be 2 times 9, which is going to end up being 18 meters. That's the speeding up part. Now, for the second part, we are moving at uniform speed. And let's be clear on this. When we're moving at uniform speed, the formula for motion is a lot simpler. It's S is U times T because there's no acceleration. Now, the thing is, we don't know what speed we're going for those 12 seconds. So the uniform speed, I'm just going to move this all down here and simply say that let's use part 1. Let's also use the equations in part 1 to get the speed. So we're going to say V is AT plus U. And in this case, when we plug in our formula, it's going to be 4 meters per second squared times 3, which is 12 meters per second. So now the uniform speed that we use in part 2, we've worked our way up to 12 meters per second, or we've accelerated to 12 meters per second, and we can actually use that in this formula here. So we can say S is 12. And then the T that we want to use is 3 seconds. And so we cover, it's 12 meters per second. And we're going at this uniform speed of 12 for another 12 seconds. And so that's going to give us 144 meters covered there. Now it says find the total distance traveled and the average speed of the trip. So finally, we're going to slow down to rest. Okay. Now we could use an acceleration formula here, except we don't have. I want to be clear on one thing. The acceleration in this part is not equal to -4. And I'm going to show you that in a second. Okay, but first I'm going to use a formula that I don't use as often to get distance, which is U plus V over 2 times T. And I'm going to use that formula to get the distance covered for the last part of the trip. Okay, so that's going to be S for the last part. S is the initial speed is 12 from here. We end up at a speed of 0 because we stop, divided by 2 times this last 6 seconds. So that ends up being 36 meters for that last leg of the trip. Okay, so the total distance, I'll write that over here. So the total distance is going to equal 18 plus 144 plus 36, which is going to end up being 180 plus 18. I'm getting 198 meters. Now, the average speed is going to be the total distance over the total time, which is going to end up being 198 divided by my total time, which is 3 plus 12 plus 6. That's 9 plus 12, that's 21. And when I actually then go ahead and isolate that out, 198 divided by 21 is going to give me, I want 2 sig figs, 9.4 meters per second is the average speed. Now, one thing I want to do if you're reviewing this, you can show that the acceleration is not 4 meters per second squared, because that would be a question that might come up in the IB, like, is the deceleration 4 meters per second squared? We can show that with this formula. We can actually do here v equals at plus u. So 0 equals a times 6 plus 12. And when we isolate, we actually end up getting that a is negative 2 meters per second squared when you actually check the work. That's just a little bit of an aside. So that is question number 3, one of the more challenging problems. And I'm really excited that so many of us were able to get either most of it done or almost all of it completely done.